This is the first part of this topic about the circular motion. It is the first chapter of the A level syllabus. So in AS level, we have learned about what we call the translation motion. That means a motion in a straight line. In A level, and then we'll learn about the first one is the circular motion. We can call it the rotational motion. Okay. So in terms of rotation motion, we instead of using the displacement, the term of displacement, we use a term we call it as the angular displacement. So angular displacement. For angular displacement, it is the angle swept or traveled by the object with reference to the reference line. So what does it mean by the reference line? That means how do you measure the angle? Where do you measure the angle? So let's say the dotted line here is the reference line, and then the angle swept. So when the object moves from this position to this position, okay, and then the angle here, the angle theta is the angle displacement of the object. And then how about the unit of the angle displacement? Oh, you said because it's an angle, so we use degree. Yes, but in science, we use radian instead of degree as the SI unit of angle. So what we will first learn how to convert the radian to degree or degree to radian. So I think radian is not a new unit for you because you have learned it in core mathematics. So for radian to degree, so we say that pi radian is 180 degree. Or for a whole circle, that is 2 pi radian, and that is 360 degree. So in mathematics, actually we can ignore the radian sign and then just say pi or 2 pi here. And then pi equal to but in physics you it's better for you to written down the unit of radian. So please don't ignore the radian, the unit of radian. Although it is not incorrect, but to emphasize the quantity. So for example, the angle displacement, the theta, and then you say is pi, that's fine. But for physics, it's better for you to write down as a pi radian. So let's do some, let's say, okay, how about 1 radian? Okay, you know this is maybe primary school calculation. So you divide both sides by pi, and then you get 180 divided by pi degree. Or how about 1 degree? So you can divide both sides by 180 and then you get pi over 180 degree. So let's give you some exercise, okay? How about to write down 90 degree into radian, and then let's say pi over 3 into radian. Okay, you can pause the video and then do it by yourself. So I'll just give you the answer here, and then what you can do is multiply the second equation by 90 on both sides. So you will get pi over 2. So there's no degree here, it's radian. So how about this one? Pi over 3 is how many degree? And then what you can do is multiply pi over 3 on both sides in the formula 1, and then you should get 80 degree. Sorry, 60 degree. Okay, that should be easy. So just like in translation motion, we have The first one we have displacement. Okay. Oh, that means how we define the distance traveled by the object. Uh, and then okay, I want to see how fast the object moves. So we have another term we call the velocity. So quite similar to translation motion. That means a motion in straight line. So we first have the angle displacement, and then we want to see how fast the angle change. So we have angular velocity. We use the symbol omega. So if you still remember how we define the velocity, velocity is the a rate of change of displacement. For angular velocity, the definition is quite similar. It is rate of change in angular displacement. So let's say if we have a let me rewrite the formula in terms of the symbol. So we use the symbol omega to represent the angular velocity. And then for rate of change, you should have learned about this one. So for rate of, it means divide by time. So actually that is change in angular displacement. Change in angular displacement divided by time, the change in time. Okay. So I think maybe just give one. So let's say if the omega, okay, I use the W, okay, to be lazy. Let's say the omega is maybe 2 radian per second. That means it will rotate the angle 2 radian in 1 second. That's the meaning of the angular velocity. So, and then let's give you one more example. One more important formula. So, if an object moves from the initial point around a circle and then back to the initial point, so it moves a whole circle, and then at this time, the angle displacement, in terms of primary school mathematics, is 360 degree. Okay, and then in terms of radian, we know that that is 2 pi radian. And that time, the time here, we call it period. And then we use the symbol big T to represent the period. So we can have a formula here. That is omega equal to 2 pi over period. So if I've given you the period of the motion, and then you can find the angular velocity by using this formula. So right now you have learned about 2 formula here. This one and also this one. So let's give you one example how to make use of this formula. So in a clock, in a normal clock, not digital one, okay, analog one. So we have the minute hand, second hand, and also the hour hand. So how about the period of these three? So for the minute hand, for the hour hand, okay, let me draw a clock. Okay, this is 12. Okay, 1, 2, 3, 4, 5, 6. Okay, and 7, 8, 9, 10, 11. That's it. So for an hour hand, it travel a circle by the time 12 hour. Okay, and then for minute hand, the period is 60 minutes or 1 hour. For second hand, that is 1 minute. Okay, and you know that we all need to convert it the unit to second, because second is our SI unit. So 12 hours, okay, and then 12 times 60 minutes times 60 seconds. For 1 hour is 60 times 60 seconds. for 1 minute is 60 seconds. Okay, so the angular speed of the hour hand is 2 pi over this one, and then just use your calculator to find it. And then that will what you get will 1.45. Okay, and how about times 10 to the power negative 4? Then how about the unit? Then the unit should be radian per second. I think all of you should be able to derive the unit from the formula. So we know that the change in the angle displacement is radian, and then time is second. So the unit of omega, angular velocity, is radian per second. So the angular speed of minute hand is 2 pi over 60 times 60. So that is 1.75 times 10 to the power negative 3 radian per second. So for last one, for second hand, is 2 pi over 60. So your answer should be 0.14 0.145 radian per second. Okay. So hope you can understand these concepts. Okay, this is the part 1 for the second motion.